This is number 44 in chapter 7. It's basically looking at electromagnetic radiation and associating an energy with that radiation. The question reads that we have a heat lamp which produces 32.8 watts of power. 32.8 watts of power at a wavelength of 6.5 micrometers. How many photons are emitted per second? So we want the number of photons per second. And so that's our question. So the first thing we want to do is relate our energy, our watts, into something that works with our energy expression. And so we're going to use our energy expression for a particle that acts as a wave using its wavelength to solve for the energy of a photon. And then we're going to relate that energy to our 32.8 watts. And so the first thing we want to do is say, well, 32.8 watts is actually equal to 32.8 joules per second. And so if we can figure out our energy of the photon in joules, then we can compare it to our energy output and determine then the number of photons. So we can solve for the energy of one photon by using our expression that involves Planck's constant times the speed of light all divided by our wavelength, which we have to make sure is in meters and not micrometers. So we have our Planck's constant, we have our speed of light, we have our wavelength, and when we plug those in, we can solve for the energy of one photon, and that energy is 3.0581 times 10 to the negative 20th joules per photon. Now we just want to use this energy output of 32.8 joules per second to figure out how many photons are being released per second. So we'll take that 32.8 joules per second and we will divide it by our value that we just got. And the reason why we need to divide is so that our joules are canceling out and we're left in number of photons per second, and we get a value of 1.0725 times 10 to the 21st photons being emitted every second. That is number 44 in chapter 7.